Yes, sir. Yes, sir.
Okay.
Allah, sir. Okay. Respected expert, Dr. Appasab Gadde, sir. Dear participant, good evening to all. It is great pleasure to introduce today's second session speaker, Dr. Appasab Gadde, who will be delivering the expert talk on industry application of AI ML in manufacturing and maintenance. Dr. Gadde is currently serving at Thapar Institute of Engineering and Technology, Patiala, and brings with him 15 years of rich and academic industry experience in mechanical engineering, design, and advanced computational analysis. He holds PhD in mechanical engineering from Sardar Vallabhbhai National Institute of Technology with research supervision involving IIT Kharagpur. Dr. Gadde expertise span computational mechanics, finite elements analysis, reliability analysis, wear and friction, and more recently the integration of AI and machine learning techniques with engineering application such as predictive maintenance, damage detection, structural health monitoring, and intelligent manufacturing system. His strong background in MATLAB, Python, ANSYS, Abacus, and data-driven modeling enables him to effectively bridge a classical mechanical engineering with modern AI ML approach. Dr. Gadde has impressive research profile with numerous SI and Scopus Index journal publication, a patent filing, and extensive experience in industry-oriented project, experimental validation, and simulation-based decision making. His work reflects a strong alignment with Industry 4.0, particularly in applying intelligent algorithm for improving system reliability, operational efficiency, and maintenance strategy. Dr. Gadde is also an experienced educator and mentor, having guided several undergraduate, postgraduate, and delivered invite talk and FDP session on advanced engineering and computational topic across reputed institute. So, dear participant, we have such a dynamic expert for this session 2. So, we are privileged to have such academician and researchers with us today to share practical insight on how AIML are transforming manufacturing and maintenance practices. So I request Dr. Gadde sir to kindly take over session. Thank you, sir, for being with us.
Just one check, sir. Am I visible? My slides are visible?
Yeah.
Is it
So your
required
slides
to
are
do any modification?
can you put in on presentation mode?
Yes, I'm trying to do it.
And if possible, you make your video on.
Video is not possible, sir.
Okay, sir. No issue, sir. No issue.
Just a minute, sir. Let me find out. Is it fine, sir?
Yes, sir. Yes.
Okay. Good evening, all of you, and special thank to Dr. Ritapure sir for a nice introduction. So before setting up the forum, I would like to mention what I am going to cover. So I'm basically a machine design guy, and my expertise lies in computational mechanics. I believe in coding since my post-graduation days, and doing hardcore coding for finite element analysis. And I started data science in 2012. Initially, I handle uncertainty quantification problem in machine design, especially by using advanced finite element analysis. And from there, I switched to lot many data science applications like sensitivity analysis, then probabilistic approaches, variety of probabilistic approaches. You can go through my publications and you can find it out. Then next I switched to AI and ML in various applications by taking the basis from my PhD work. And recently I'm working 3 pioneering problems in mechanical engineering and where full-fledged AI and ML applications are there. Problem number 1 is agriculture problem. It is just for detecting maturity of the fruit by using deep learning. And I'm collaborating with Khalifa University, Dubai for that. Recently, we published one paper in Q1 journal. You will find that paper in my Google Scholar profile. Unfortunately, I have not shown my papers here. Then second problem I am dealing with is problem of wear and friction. Normally, you might be knowing wear and friction is a hardcore mechanical problem, and it takes a lot of time to do experimentation. I have done it in the past also. So I fed up with the time and the efforts required to find out the results. And that will be my motivation to deal with this problem. And third kind of problem which I am doing recently is a problem of exoskeleton biomechanics. I received grant from variety of funding agency for that. And I am working rigorously on that. And all these problems need AI and ML. Now, before starting, I would like to mention you about my experience about AI and ML. The first and most important experiment is, it is my opinion, I may be completely wrong because that conclusion came on the basis of very little experience in AI and ML. So I feel that AI ML is an optimization tool. If your problem is not strong, AI ML is a useless. I am using little bit of harsh word. But if problem is strong in respect of number of parameters, then in respect of the accuracy of the problem, we can divide solution of the problem into 2 parts. Deterministic solution, other one is uncertainty quantification. And AI ML lies into the second part, uncertainty quantification. Once I get the result, I will have to play with the result. And that can be done with the help of ML. So ML will totally, that means input to the ML is the results we are getting in mechanical engineering. Problem may be anything. It may be thermal, manufacturing, production. And normally we are getting that result in terms of data. And most of the times, previously, I think a lot of mechanical engineers use Taguchi method, then lot of many statistical techniques to optimize that data so that we will get a proper conclusion of the data. And that Taguchi technique and all these things are over the period of time, now it is obsolete and it is replaced by machine learning. Now, I think one question I heard in previous session, which algorithm is to be used for which application? This is a very nice question. So I would like to deal to it as per my capacity. Most of the times, we go by code of the machine learning algorithm, which is available in online domain. And in that case, we enable to understand mathematics of the ML algorithm. And if you start ML algorithm from mathematics, then you will be in a position to identify what will be the nature of your data and which algorithm is suitable for it. Normally, reviewer captures this situation. The nature of the data is different. You should have to understand the nature of the data. And the algorithm used is different. Total selection of algorithm totally depends on what is the nature of a data. Then another aspect is how much accuracy you want. Accuracy of the prediction and accuracy of complete problem. How much accuracy you want. Suppose your problem is to predict the traffic in metro city like Pune, and you are using some algorithm which is not suitable for that kind of data. Then reviewer asks this kind of question. So mainly today, what I am covering, I am just starting with the basics of machine learning that you all might be knowing. It will be just a repetition. And then I am showing you some results, my recent results. I just, one paper is accepted and other one is under review. So I am showing results of that paper. And both the papers are for tribological problem, wear and friction. I took results of wear and friction and then try to predict the wear and friction by using machine learning. That is the main theme of today's presentation. So first of all, I will start from machine learning. Again, it is very basic. And I started from a Wikipedia. I got recently a little bit information, and it is just for setting a tool. So I will give a lot of credit to this person, Herbert Alexander Simon, born in 1916, and he worked up to 2001. So his during his lifespan, he has a huge contribution to the machine learning. He's an American scholar, and surprisingly, he is economist, and he has developed so many machine learning algorithms. He's a father of machine learning. Then from his publications, I tracked out few things, and I'm putting in his own word what is a machine learning. This is Herbert Simon. Then Simon has proposed three famous stages in the rational decision making. And these three stages are intelligence, design, and choice. And these three words define the AIML can be used in any domain, because any domain required intelligence. Then we have to use design strategy, and at the end we have to do a choice. And that is the reason AIML will be suitable for any kind of fit. So it will look like this. Simon's three activity stages in decision making. First one is intelligence gathering. Intelligence means it is gathering up information. We can call in our language, it is just a collection of data. Now that intelligence gathering can be done by using this trick: search environment for a condition, calling for decision. So what kind of data you want? Now in my case, I want to make a decision of what will be the coefficient of friction and wear rate under this situation. So I should know the data. If my data is not correct, then ML will be like a black box. It will predict a wrong thing. That's why intelligence gathering is very important. Now suppose problem is of economics, and that economics is for the welfare of the human being. The data is again very important. Now once I got the data, then my next step is I will have to interpret that data. That means I will have to decide what is the input and what is the output. Now suppose input is based on the 10 parameters and I am getting one output. Now here I will think about the problem and I will try to prepare my design strategy. If you go through the design process, there also we are doing same thing. We are collecting the data in terms of a need of the problem. And once you assure that there is a need of the problem, we just start implementing the design process. Now we are in design, possible course of design: invent, develop, and analyze. If there is any participant from mechanical design, he has to go through these three stages. And this will tell us why we are using ML, why ML is important for mechanical engineers. Okay. And last one is a choice. Select the particular course. Now that choice may be just optimization of data and drawing a conclusion. Yeah, it may be extrapolation of data. It may be interpolation of the data and predicting the outcome. So this is the three activities or three stages which proposed by Herbert Simon, and that too in 1940s. That was the era of Second World War. Then he proposed, as per his statement, learning is any process by which a system improves performance from experience. And if this kind of situation is there, suppose I don't have a new data, in simple language, for mechanical engineering problem, for any engineering problem, first of all, we have to think about the problem, and then we have to prepare its physics. Why to prepare a physics? The only thing is that we can imagine about the problem before starting the work. And that is the need, we need a physics. And ML eliminates that physics. Okay, instead of framing the problem with the help of the physics, which is a little bit tedious task, many of you might have heard about the mathematical model of the problem. It is a little bit complicated and little bit tedious task. Now, instead of deriving the data from the physics, what I will do, I will collect the experience about the problem. And that experience helps us for a future learning. And it is called as a machine learning. Then machine learning is connected with computer programs that automatically improve their performance through experience. Now for that process, suppose data is in huge in amount. If data, the number of the data is less, we can process it manually. But if the data is in large number, in that case, we have to take support of the computer. Support of the computer means what? It is support of the statistical tools which are available built into the computer. And that statistical tool help us to simplify our job of using machine learning. Then one more scholar, British scholar, Alan Turing, rightly questioned in his paper, can machine do what we can do? We means thinking entity. Human beings are the thinking entity. And the answer is yes. He proposed this question in 80s. He just extended a work of Herbert Simon, and he proposed this question. And all of these becoming possible due to artificial intelligence and machine learning. Now, machine learning, as per the in 1959, one more author, Arthur Samuel, he has done again great work into this domain, machine learning and decision making. And as per his opinion, field of study that gives computer the ability to learn without being explicitly programmed. This is again very important. Once you build up the physics of the problem, next step is to build up the mathematics of the problem. Why to build up mathematics? Because as if I have to do the automation of the decision-making process, I will have to use computer. And computer understand only mathematics. And that requirement can be eliminated, can be simplified with the help of the machine. I am trying to make here a point why machine learning is useful for engineers, not only mechanical engineers. Then in 1998, Tom Mitchell defined machine learning little bit in mathematics. Machine learning is the study of algorithm that improves their performance P. Suppose performance is denoted by P at some task T with experience E. And if you start machine learning from this mathematics, you will be able to understand limitations of each and every algorithms. You will find n number of algorithms in a public domain, and there will be a huge amount of confusion which algorithm is to be used for which problem. Then, by looking at the data, we can find out what performance I will have to improve, and what is the task given to me, and what is the experience I have. And from that, we can conclude which algorithm is to be used. Now, we'll define learning task is a function of P, T, and E. Here, P is the performance, T is the task, and E is the experience. This is about what is a machine learning. Then little bit extension to it. What actually happens to that means I told you in previous slide, the importance of the programming. So there are two kinds of programming. One is traditional programming and other one is machine learning. So here we will try to understand what is the difference between these two types of programming. In traditional programming, we can use a data. Data can be given as an input to the program, and that program and data is fed to the computer, and computer gives us output. This is the traditional programming in any language for any problem. But what machine learning does? Machine learning give output as an input. That is the specialty. And machine learning built upon a program. And that program helps us to predict that program helps us to optimize the problem, optimize the data. And this will be very much helpful in a decision making. Output of any machine learning is to improve the decision making process. It may be the decision making in economics, in agriculture, in mechanical, civil, electrical, whatever may be the domain, medical. The main role of the machine learning is to improvise the decision making process. Then what are the applications of the machine learning? These are the few representative applications. Okay, it can be used for a speech recognition. Most of the time, suppose speech is delivered in one language, and we have to modify it for other languages. We have to recognize the speech based on the lip movement. Then facial recognition. This can be used by cyber people for investigating the crimes. Then image recognition. Then mechanical people are building up the autonomous driving cars. Then I will in brief tell you it's a history also. Then when do we use machine learning? In which case we can use the machine learning? So ML can be used in the first case is human expertise does not exist. Example is navigation on a Mars. Suppose we want to navigate something on a Mars, then in that case, ML can be used. Example is this. Then humans can't explain their expertise. The application is a speech recognition. Then the models must be customized. For example, personalized medicine. There are a huge amount of data available for this human being. This medicine is applicable for this disease. This medicine is applicable. So from that data only we can predict what disease I have and what medicine is to be used. These are the very basic and simple applications. Then models are based on huge amount of data. Sometimes we get confused about the data. Data is huge and we are unable to draw the conclusions. It is as good as crowd is throwing questions to us. Okay, everyone is asking different questions. And it will be very difficult for me to interpret. Then in that case, we can go for a ML, machine learning. So it will be like this. Suppose data is in binary code, then data is in numbers, and I am able to interpret about the data. That means total chaos is there. Then in that case, we can go for a machine learning. Then when machine learning is not to be used. Okay, learning isn't always useful. There is no need to learn to calculate payroll. Okay, you cannot decide a salary of a person depending on his previous salary. It is just a joke apart. So in that situation, we cannot use machine learning. Then some more examples of the machine learning. These are available in a public domain. So recognizing patterns, generating patterns, then recognizing anomalies, then prediction. These are the few tasks can be done with the help of machine learning. Then sample applications of the machine learning. There are so many areas. Web search, computational biology. Okay, then recently people are using these ML techniques for cancer, prevention of cancer and prevention of so many diseases. Then finance, e-commerce, space exploration, robotics, information extraction, then social networks, debugging software. You can go on adding the areas. Then what is these are some recent headlines about the deep learning. And this tells us the severity, the community, where communities going about deep learning and the machine learning. Then the main thing for selecting the machine learning algorithm, for using the machine learning, so what task we have to perform from the machine learning. So for that, I am just giving you representative examples. Here task is what? Improve on task with respect to the performance matrix P based on experience E. So suppose T is the task. Task is what? Playing a checkers. Then how performance is to be measured? Percentage of games won against an arbitrary opponent. Then what is the experience? Playing practice games against itself. And that experience helps us to perform better. Then another example is task is suppose recognizing handwritten words. Then percentage of words correctly classified will be the performance. And database of human labeled images of handwritten words. Then another example is driving on a 4-lane highways using vision sensors. This is the task. Then performance is what? Average distance traveled before a human judged a error. This is the thing which helps us to measure performance. Experience is what? A sequence of images and steering commands recorded while observing a human drive. Then another example is categorize email messages as a spam or legitimate. This is the task. Then performance matrix, percentage of email messages correctly classified. And what is the experience? Database of emails, some with human given labels. Most of the times we are unable to deal with these things. And we just go on using the machine learning algorithms because in research papers, if some algorithm is used, and for the task, suppose I am using some different algorithm, and that is the reason I am getting novelty. So if you have to come out of these, you have to define these 3 T, P, and E first. Then a little bit more about the autonomous cars and its reality. This is what happening today. These are the few representative pictures of the car. In America, there are 4 states. They are making it legal. And recently, I don't have a data, but the people are moving very rapidly in this direction. And in autonomous car sector, AI is playing a vital role. Then what are the different types of learning? In short, I am just taking the representative types of learning. One is the supervised learning. Okay, what is the specialty of the supervised learning? Given training data plus desired output. We call it as a labels also. This is the given. Then unsupervised learning, given training data without desired outputs. It is called as unsupervised learning. Okay, if output is given, output is there, and then we call it as a supervised learning because our data is based on the output. But data is not based on the output, but I have just a readings and I'm just predicting the output. That kind of situation is called as unsupervised learning. Then semi-supervised learning, training data plus a few desired outputs are given. So while selecting the algorithm, we have to check these things also. Which algorithm can be suitable for this application? Again, it depends on what kind of that algorithm is built on which type of mathematics. Yeah, what is the mathematical capability of the algorithm? Then reinforcement learning is one more type. Rewards from sequence of actions. I have a data of actions and I'm predicting the next action. Then supervised learning sub-categorized into two parts. One is the regression and second one is the classification. So regression is given, suppose x1, y1, x2, y2, up to x and y1 is the data. Then learn a function f of x to predict to y given x. Okay, it is simple mathematics of the problem. Whatever we discussed theoretically now, we are just trying to put it into a mathematical form so that computer will understand it. Now here y is what? It is a real value. And if you plot this, suppose example is what? The September CIs, and over the period of years, the data is given. Then supervised learning classification, the example is this. Suppose ML is used for predicting the cancer. That in that case, you can predict the tumor size. Okay. These are the few classical examples of when we can go for a regression and the classification. Then supervised learning, the overall flow is this way. I just picked up this from Wikipedia. The raw data is the input, then algorithm, then processing, and you will get the output. Then unsupervised learning, the further explanation is this. Suppose data is not given in terms of x1, y1. It is given in terms of x1, x2 up to xn without labels. It means output is not there. Then output hidden structure behind the x. Okay, so this can be solved in this. Then in unsupervised raw data, interpretation is required over here, and then algorithm, then processing, and then output. These are the 4 steps. Then the reinforcement learning, given a sequence of states and actions with delayed rewards, output of policy. Okay, then policy is mapping from states, then actions that tells you what to do in a given state. For example is credit assignment problem, then game playing problem, then robot in a maze, then balance a pool on your hand. These are the few examples of where we can go for reinforcement learning. Then in reinforcement learning, you can just, this picture will be self-explanatory. Input raw data. And the 2 things comes into the picture. One is the agent and another is the environment. Then the best action, then selection of algorithm. In reinforcement learning, we can use n number of algorithms, and then you will get the output. Then the role of AIML in modern mechanical system. I am starting with my case study now. This much I think is sufficient for just the basics of the machine learning. There are many things available in the public domain, but I just selected a representative aspects just for setting of the background for the problem solution. Now I am considering here tribological problem, and here I use 2 ML tools. One is I just use machine learning algorithms for prediction coefficient of friction and wear rate. And in another case, I just played with the parameters and I used the importance of the parameters, and I used deep learning techniques and sensitivity analysis technique. And in detail, I will tell you when I go to the case study number 2. Now here, the primary source of energy loss and component degradation is friction. Why we need a friction and wear? Because once I get the coefficient of friction, the design people can understand its importance. We can find out the energy loss, and we can predict the life of the component. Then the every mechanical component has to operate in a different operating conditions, and that operating condition, we cannot imagine a mechanical component without a load. So load is there, then we cannot imagine mechanical component without a speed, and we cannot imagine any kind of mechanical happening without a time. Then in mechanical engineering, we cannot imagine a one rigid body. There is a combination of the rigid bodies. Then we have to set up what kind of quantities among the rigid bodies. And the combination of all these, we call it as a machine. And then here, we can go up to the manufacturing of these components. Now, that composition requires some material. Now, in that case, I will have to check what will be the material is altered, composition and reinforcement governs surface behavior. Then one more aspect which is dealt by mechanical engineers is a non-linearity. In fact, everything is a non-linearity. Whatever we are assuming is the assumption. The assumption of linearity helps us to connect with the physics and build up its mathematics. Now, once we build up a mathematics for a linearity, it is our duty to extend it up to the non-linearity. And this will help us to deal with the real life problem. But most of the times we left our problem up to linear level only, and we try to make a conclusions. Same is the story of the static and the dynamic. Nothing is static. Nothing happens within zero time. Every occurring requires a time. That's why for connecting with the physics and mathematics, it is very much essential or required to start the problem from the statics, and it is to be extended up to dynamic. Then in mechanical engineering, the days are gone now to deal with the experiments. Okay. If you are, why it is not possible to deal with the experiment? It is main thing is the time required. If you are trying to predict the performance of the component, future performance of the component by doing experimentation, it will take a huge amount of time to bring our product into the market. And we will lose the age. And in that case, AIML is again required. Then, what we have done in this tribology problem, the main thing is the data acquisition, collecting high resolution experimental data from pin on disk experiment. I think many of you might have come across with this experiment. Okay, I think in Maharashtra, DCOM based VR testing machine is there, and many of you had that experience. Then triboinformatics, structuring raw experimental results into digital feature vectors to map hidden correlations between material parameters and wear rates. Here, material parameters we consider is a reinforcement percentage, and then parameters of the specimen, how much is its sliding distance. Then we consider load. Then we consider time. Then machine learning framework will be the third aspect. We call it as a computational engine. Then implementing advanced algorithm to learn the nonlinear input-output relations of the system. Now we experiment data of any tribological system. Yeah, tribological problem is one is the dynamic, and it is highly nonlinear. Then it is very easy to deal with a linear problem. But for a nonlinear problem, if you're trying to build up the equations will be unending there. And there, suppose somehow we able to develop the equations, then it is very difficult to solve that equations because of the limitation of the computational power. And in that case, we can take support of ML. Then predictive intelligence, engineering outcome, the virtual prediction of friction, wear, and dominant mechanisms. These are the 4 tasks is to be done in case study 1. Then what kind of material we consider? We consider aluminum matrix composite, and that aluminum matrix composite is reinforced with the boron carbide. Then our target application is aerospace or automobile applications. Then the tribological performance governed by interactions between material composition and operating conditions. These are the main 2 things we are bothering about. What will be the reinforcement percentage which is to be used for the optimal performance of the aluminum metal matrix composite? And then what kind of operating conditions are affecting the performance of aluminum metal matrix composite? Then we formulate a problem in a simple word, tribological behavior prediction under varying load, then speed, sliding distance, and reinforcement conditions. These are the 4 important parameters. And what is the objective? To predict the coefficient of friction and wear. This is just the ML framework for predictive tribological modeling. This paper is just we sent the review comments and we hope it will get accepted. So we just prepare our data on the basis of this. The first is a data collection from pin-on-disk experiment. Then data cleaning. In pin-on-disk experiment, you might have observed sometimes raw data will be there. Yeah, due to the operating conditions, there will be a sudden jump of the specimen, and that jump get added into the VR data. So we have to identify that, and we have to eliminate that data. Again, here we have to eliminate data by considering the technical aspects of the data. You have to exactly find out where that jumping takes place due to the contaminants, some impurities between the contact at the contact point of the pin and the disk. So some fake data will come, to data cleaning will be there. Then data normalization is there. Okay, and last step is splitting of the data. Now in our case, we 70% data. Again, someone will ask why 70, 15, and 50. It depends on nature of the data. We just gone through the data and we feel that 17, 15, 15 will be the quite sufficient. And all of the reviewer agreed on that. No one has raised the question about it. Then this is the experimental setup. I think many of you might have seen this. We conducted test at one of the college in Karnataka. I forget the name of the college, and we obtained data from there. Then ML framework, for the main framework, we have complete flowchart of the work. Our work starts from the data, material selection of EL7. These are the two materials selected. Then the reinforcement considered here is 0%, 4%, 8%, and 12%. And for that, we took support of literature, then industry inputs. And we got to know that in this kind of material, people are using this kind of reinforcement percentage. Okay. Then perform pin-on-disk wear test. Then we have done SEM and EDS also, just to get the clarity of the surface, accuracy of the things. Then we collected near about 10,800 data. This is the amount of the data which we are processing into the experiment. Then we used here 3 algorithms: ANN, SVM, KNN, DT, and random forest. These are the algorithms just used for reference purposes. And we developed our own model, which is a combination of a number of things. And we named that model as a WFEL. Means wear and friction in assemble machine learning model. Then for that model, we obtained our result. And as usual, you might be knowing, for any kind of ML problem, we have to find out R square, MAE, MAC, and RMAC. Now, algorithms used in this works. Conventional algorithm, I told you already, we used ANN, SVR, and RF. And this is the algorithm in assemble and friction, wear and friction in assemble machine, WFEML. This algorithm we used for our work. Multi-stage in assemble framework for predicting coefficient of friction and wear rate. Now here is just a glimpse of the algorithms, standard algorithms. These figures and all this information is available in public domain. So I have not put up any kind of reference for here. So ANN, the nature will be like this. It consists of interconnected processing units. We call it as a neurons, and arranged in a functional layers. Then concept of the ANN will be this. Again, we took support of ChatGPT here, and this research paper is there by Argawatal, published in 2019. And we got this information about the ANN. This is suitable for experimental data sets with complex interactions. This is the case of our problem also. Then capable of capturing strong non-linearity in friction and wear process. Then support vector machine. Support vector machine is supervised learning algorithm. And this algorithm gives us comparatively good result in comparison with ANN also. Then in support vector machine, the one word kernel function. I think someone that kernel function is a mathematical function that transforms low dimensional input data into a higher dimensional states. Now, what are the common kernel functions used in our work? linear kernel, polynomial kernel, and radial basis function. We call it as RBF in short form. Then this SVR is suitable, effective for small and medium-sized experimental data sets. And kernel trick enables non-linear regression without explicit transformation. The main role of the kernel here is to take care of that non-linearity. Most of the times I have gone through the many papers where data is too much linear and still people are using kernel. So these are the few tricks which we can adopt for deciding which algorithm is used for which application. Then random forest. The basic idea, multiple decision trees are trained on the different bootstrap techniques. Here we use the bootstrap technique also. Now each tree learns a slightly different data pattern. Working principle is this. Now why we are using this in our problem, naturally handles nonlinear and interactive parameters and works well with the mixed scale experimental data. Okay, and this our conclusion is well supported by this Rosen-Krajcik et al. 2020. Now nothing come all of a sudden in our mind. We always remain with the research community across the globe, and we try to ensure that whatever conclusion or selection we are doing, it is as per in line with the research community. Then why we need this WFEML? Now single ML models, as we discussed, ANN, SVM, RF, show limitations across wide tribological conditions. Now in tribological problem, conditions are very wide. Then tribological data exhibits strong non-linearity that I told you already, and parameter coupling. And to tackle that, we have to go for a little bit a different ML algorithm. Then a robust framework is required to improve stability and generalization. Now, what is the concept of WFEML? It is just a multi-stage ensemble learning framework. Then it integrates strengths of multiple regression models. That means the prediction can be done in a phases. And that phases is the improvisation over earlier phase. Then designed to deliver robust coefficient of friction and wear predictions. Then what input and output parameter considered here? Inputs are load, speed, time, sliding distance, and reinforcement percentage. And output is coefficient of friction and wear rate. These are our tribological results. We just plot that result based on the data. This helps us to just understand more about the data. And for that only we plot this result. And that results shows whether the results are accurate or not if you compare it with the already published work. That means in any kind of statistical experiment, we need to validate our deterministic part. This is our deterministic part. And this particular plot tells us that we are in line with the research community who already work solely on the tribological experiments only, but they have not used any statistical tools like machine learning. Okay, and this will help us to gain the confidence in our data. And once you ensure that key deterministic results are accurate, then your ML results will be again accurate. Yeah, people will show faith on your ML result. This is again tribological results, coefficient of friction versus load, and wear rate versus load. Again, it is in line with the published literature. Though I have not compared it, but it is well known in which condition this aluminum metal matrix composite shows higher coefficient of friction. Then these are the SEM results. Again, this is just to ensure that whatever we have done experimentally is correct or not. We compare this with the already published results and we make sure that our data is not a weak data. This is our main architecture of this ML model. I told you about the phases. 4 phases are there. Basically, phase 1 is for capturing non-linear tribological behavior of multiple models. Now here we used ENN, then SVM, basic models we used. Then phase 2, it is ridge regression stabilizes ensemble predictions. Then phase 3, here role of a kernel comes into the picture. Kernel modeling refines prediction accuracy. And phase 4 is what? Final model evaluation. And this improvises the accuracy of the evaluation. Then little bit description about these four phases, as it is aggregation of these various basic algorithms. So it just raises the importance of the work done. Then here multiple regression models are used. These are the random forest, XGBoost, CatBoost, and bagging regression. All the codes are available in online domain. Then this is just mathematics of WFEML. What mathematics we employed for preparing our code. Then these are the results. WFL prediction performance. Okay, you can see the improvisation over the result. The WFML R-square values are compared with the ANN and SVM. In this case, you can show the improvisation over result. The first is for wear rate, and table 2 is for coefficient of friction. Then WFL prediction performance for wear. Prediction of wear rate in micron over here, and actual wear rate is this. The result shows that the predicted and actual will be in line. Here, residuals, it is as good as the things which are unable to capture into the ML algorithm, that can be plotted in this manner, and actually where it will be this. Then predicted COF and actual COF, and residuals and actual COF. Then other model predictive performance for ANN, then support factor regressor, we got this prediction. Then earlier one is for wear rate, this one is for coefficient of friction. This is just representative results of what work we have done. In research paper, you will find the results in detail. Maybe next month it will come online. Then we found some limitations of our work. What are the limitations? Here, prediction accuracy is improvising, but we are saying the prediction accuracy alone is not sufficient to draw the conclusion about the problem. And this will be the motivation of our next extension of our work. Now, high prediction accuracy does not guarantee interpretation. Then in-assemble and deep learning models behave as black boxes. There is no interaction between the various parameters is captured in the right manner in almost all ML algorithms. Now, engineers need to know which parameter dominate wear and friction. So that in design phase, you find out the parameter, because in manufacturing phase, I cannot control all the parameters. Now here, if I know the dominant parameter, I will take much more care of the dominant parameter. So then lack of interpretability limits industrial adoption. Now this limitation will be the motivation for our next work. And that next work is a sensitivity analysis in a tribology. It is extension of prior research. This paper is again under review. It is submitted to Q1 journal. Then what sensitivity analysis does? It enhances engineering interpretability. Then identify dominant design drivers. Suppose out of the 4 or 5 parameters considered here, I found that here reinforcement percentage is very important to obtain the critical outcome. Then I will make sure that the reinforcement should be uniform. Then a reinforcement percentage should be accurate. And this will help us to enhance the friction and wear performance of aluminum metal matrix composite. Then the sensitivity analysis helps us to address this black box nature of the AI. Then the sensitivity analysis and AI framework for tribological prediction. Here we have done this the 4 tasks. We have done global sensitivity analysis. Now here we employed these 4 methods: Sobol indices, delta index, Pon index, and mutual information. Now in literature, this sensitivity analysis is used for variety of problems. It is for medical problem, then economics problem, then problem of controlling traffic, and we just try to employ it for mechanical engineering problem. Then advanced deep learning technique is used again to further improvise our prediction capabilities. Now here, in this case, we use deep residual regression network, DRRN, which is again a famous algorithm available in the wide body of the literature. Now our workflow in this case is experimental data. Then DRRN prediction is a deep learning, yeah, machine learning. And extension of the machine learning is GSE, yeah, global sensitivity analysis. And this will be the complete solution of the problem. This will help me to understand more about the data, more about the various parameters, and more about the interaction among the parameters. This is our flow chart for global sensitivity analysis. Then here we use a DRRN. What is DRRN? It is a deep learning technique. It learns both the direct mapping and residual correction simultaneously. Then it combines depth, non-linearity, and residual learning, because in ML we found residual and we analyze residual about our predictive capabilities. Then what are the advantages? It captures complex nonlinear relationships, which is highly available in tribological data. Then residual connections mitigate vanishing gradient problems in deep networks. And still there are limitations of this deep learning ML model. It requires large data sets compared to the conventional ML model. In our case, data set is 1,000 in numbers. So we feel it is quite sufficient to deal with this. Then computationally intensive training process. This is our architecture for this DRRN and global sensitivity analysis. Here we considered these 4 parameters. T stands for a time, weight percentage is reinforcement weight. Then phi is sliding velocity, D is the sliding distance, and L is the load. These are the various parameters considered for sensitivity analysis. Then here, these are the sensitivity analysis tools, which can be used for comparing the interaction among the parameters. This is our sensitivity analysis results. We used 2 types of sensitivity analysis. One is the first order and total order. Now here for parameter 1, the total order sensitivity index will be up to this 0.3 and first order is up to 0.1. Okay, so the result will be like this. A is for a coefficient of friction and B is for a wear. Now here in both the cases, you will find that this weight percent is more dominant. For getting the good performance of the material, a component which is made up of from this material, we need to focus much more on the weight percentage. And then next comes is sliding velocity by taking the tribological results. In both the cases, the same thing is there. Then for wear rate, these are the various parameters. Here again, weight percentage dominates. Then weight percent dominates over here in this case also. Then here also weight percent dominates. Then in last method, PON index, here also weight percent dominates. Now the interestingly, D dominates in a PON index and L and V dominates in mutual information. So this gives us a little bit information about the importance of the various parameters. Then for a COF, again, weight percent dominates in almost all the cases. And time is immaterial because things are repetitive. Now this tells me one more thing. The wear is very slow. And that is the reason the T is less important over here. So for getting more accurate result, I will have to increase T. This will help me to understand how much time is to be considered in a wear test. The dominant parameters found after the analysis is B4C represents that I already told you. Secondary is sliding velocity and sliding distance. Then sensitivity trends align with the experimental and typological behavior. And this confirms physical relevance of the AI-based framework. Then here B4C reinforcement significantly enhances wear resistance with 12 weight percent B4C composite reducing wear rate by 74%. So this analysis helped me to draw this conclusion. That's all from my side. Any question, you can ask me the questions, please. Sir, can you hear me, sir?
Yes, sir. Yes.
That's all from my side.
Okay, sir. Participant. Hello. Just I will unmute.
Ridhapuri sir, this is outcome of a late night lecture.
Just wait. Yes.
Hello.
Hello.
Yes,
Any
sir.
question
Yes, sir.
from the participant?
Sir, it
hello?
is Milind Dubey from Pravara
Hello?
Road Engineering, Pangloni.
Yes, Milind,
Am
go
I
ahead.
audible, sir?
Yes, Milind, go ahead.
Sir, my question is regarding the work that you have done on by using AIML technique.
Mhm.
Sir, can you share your work in the form of the program that you had used for getting the data and for doing
Sir,
the
just wait for one more month. My work will be online domain, and
okay, sir.
I published two paper on this work. The one paper is revision comments are submitted, and as
Okay,
per
sir.
my observation, it will get accepted.
Okay,
It will
sir.
be in online domain, and for other paper, it is under review.
Okay, sir.
Maybe just wait for 1 month only.
Sure, sir. Sir, if possible, can you please share your contact details so that I will be able to call
It
you
is
or
available in online domain. You just type my name,
Sure, sir. Thank you, sir.
email, and everything will be available. I will be very much happy to work with you all, guys.
Hello.
Sir.
Gurde sir, you have delivered nice
Sir, wait,
presentation to
Allah
the
sir.
participant. Huh?
Thank you, sir. Thank you very much,
Allah
sir.
sir. Allah sir,
Yeah.
please wait. Participant can ask more questions.
Hello, sir.
Yes.
Sir, am I audible?
Sir, please.
Yes, Rakesh,
Yes,
go ahead. Rakesh, go ahead.
Sir, can you show the slide where the models predicted the data, right?
Yes. I will share it one second. Which slide?
The models, the machine learning models have predicted the data. You have shown me the trend.
This one?
Yeah, yes, sir. Maybe all models slide would be good to initiate discussion.
Yes.
Maybe the slide number 33.
Just a second. This one?
Yes, sir. Just I want to know, like, you have mentioned here actual wear rate versus predicted wear rate. Predicted wear rate is the rate predicted by machine learning model, whereas the
Yes.
actual rate
Yes.
is from the experimental data. Am I correct, sir?
Yes, sir. Yes, sir. Yes.
But the data seems to be enormous. Do we have that much experimental data?
Sir, data, we got results per second. If you have work with decom pin on disk experiment, now you will get result per second.
So what is your experimental data samples?
See, I collected coefficient of friction and wear per second. If you go look towards the data acquisition system of friction and wear monitor, decom make, you will get data per second. Suppose I run my test for a 10 minute. So 16 to 10, 600 will be the data. Are you getting my point?
Means like, suppose we have 4 to 5 input parametric conditions, maybe impact velocity.
Parameters are less, but here the specialty of the problem is data is highly non-linear and data is a dynamic. Because in wear problem, if you draw the trend of the wear and friction, you will find that most of the data is going offset. And it is because data has a highly non-linear nature. You can think about the operating conditions also. Here load in this case we considered is a higher load. The main reason is we want non-linear data over there. We have tested 36 samples And
Yes,
every sample we are getting results per second.
So if I understood correctly.
Sir, you are not audible.
Am I audible, sir? Am I
Yes,
audible?
yes. Now you are audible.
Rakesh sir.
Yes, sir. Sir, you have conducted 36 tests.
36 experiment. Yes.
Out of 36 experiments, per second you have collected the wear rate data.
Yes, wear and coefficient of friction.
Understood, sir. Thank you, sir.
Okay. You will get Excel file out of that wear and friction monitor.
Okay.
तू काही इथं काही डायग्राम काढते तुम्हाला मा अभ्यास नाही का
Next question.
घेऊ द्या बरं झालं
I think someone get unmuted and sir. Hi sir, good evening.
Good evening. Go ahead, please.
Sir,
Just
can you please show the architect of the algorithm that you have say used
Yes,
or
yes,
say?
yes, yes. I can share. Is it feasible?
Yes, sir. So, sir, just for the sake of my knowledge, can you please just briefly explain, sir, how it is different from the
In simple language, I
benchmark?
can explain. Instead of using one machine learning algorithm, we used multiple machine learning algorithm in phases.
Okay, sir.
Okay, and the result after one phase are getting optimized, and all. It is just like a filtering out process. It is just a new concept coming into the ML. Suppose there is a data and you are predicting outcome by using some one machine learning algorithm and you are comparing it with the other. Instead of that, we clubbed all the outputs and given it to the phase number 2.
So, in this context, sir, do we have certain standard function in order to legitimize our models?
Yes,
Like in optimization, we do have.
Yes, lot many standard functions are there.
कोण जाईल
Okay, sir.
उगलेवाला
Any other question?
मला कोणती नाही म्हणतेस नाही माहिती शेवटच्या म्हणतो
मुलाचा आवाज आहे हा, लक्षात येत नाही.
कोपरे ही बारीक
Any more question?
In continuation with the previous question, this is Rakesh.
Rakesh, go ahead, please.
Can you speak loudly? You are not audible.
Am I audible now?
Yes,
Yeah,
Rakesh, you are audible.
So you mentioned like you have conducted 36 experiments and you have collected wear rate on a timely basis. But for those 36 sample size, the input conditions would be constant. For instance, for one sample, for one experiment, you have collected maybe 500 wear rate data.
Yes.
But the input conditions would be
Rakesh, your voice is not clear.
Actually, sir, please muted all participants once. That will work,
okay.
I think.
Sir, is my voice clear now, sir? Sir, is my voice clear?
Yes, sir. Please continue. Rakesh sir.
Yes, sir. Sir, my question is continuation of the previous one. Like for assume like you have conducted 36 experiments, and for each experiment, let us assume that you have collected for each experiment wear rate of 500 output responses. And for those 500 output responses for one experiment set, the input conditions would be same. Am I correct, sir? Sir, am I audible?
Just wait. Gadde sir.
Yes, sir.
Please.
Sir,
Rakesh sir, you are right. For one set of the data, we conducted test for suppose 5 minutes. Then we got result per second.
let us assume that for one experimental set, you have collected 500 wear rate responses.
Yes.
So for those 500 wear rate responses, the input condition would be same, right?
Yes.
So you have 36 input conditions, but the output responses would be non-linear. Am I correct, sir?
Yes.
Okay, sir. Thank you.
But time is not the same. Time is increasing.
Okay.
Time is
Okay.
varying again.
Okay. Okay, sir. After your paper gets published, I will look upon it.
Okay. No issue.
Okay.
Any more question?
Please unmute yourself and then ask questions.
Sir, just one addition, sir. I'm taking much time, I think so.
Yeah, it's fine. No issue. You are most welcome.
Actually, sir, when we were doing the experimentation and you have quoted that the trends were similar as quoted by in literature, they are doing the less number of experiments. Then we have done the same experimentation in taking number of readings more than that, the traditional one. Then what specific findings, what we got using investing that much, say, instruments, sensor and all, what exactly we got from that? Trends are similar.
I will have to just test the nature of the data, what I am getting from the wear and friction monitor, whether that data is accurate or not. And that accuracy of deterministic data, I verified with the literature.
Okay, sir. If someone is carried traditionally and having, say, 2 to 10, 12, say, in the same line, it is going.
Yes,
But
I am just trying to verify in which condition how that aluminum metal matrix composite behave. Once I understood that behavior, that will help me to predict accurately in future predictions.
Okay.
That means I told you about P, T, and E, performance, task, and experience. I am correcting my experience.
Actually, sir, my maybe I'm maybe new to this line, but point is someone just asked. We are having the input same, but the data is somewhat varying. So we are having 500 data points for the same inputs.
Yes.
That might be slightly varying in output, but input conditions are the same. So
And that
when
is the
a
reason
machine learning,
that is the reason the data is a highly non-linear.
but the input conditions are same, na sir. It is
Then
going to learn from
what
the
is
input
the what
condition
is the
also.
linear nature and non-linear nature? The input is same, but output is varying.
No, sir.
I will
Okay,
tell
sir.
you one condition. Load is supposed to be
Linear and non-linear, as far as my understanding, I think if we are having say y equals to mx plus c kind of, that is kind of linear, but non-linear is kind be exponential and that kind of things. Maybe I will be in touch with you, sir.
Sure. No issue.
I do
No issue.
have confusion, sir.
Yes.
Okay, sir.
Okay. Any other question?
Yes. Any more question from participant? Aldar sir.
Yes, sir.
Hello. Yes.
Please conclude.
Mr. Gadde sir has given Dr. Gadde sir has given very good session on the artificial intelligence and machine learning. He has given insights how to design, how to use the intelligence, what would be your choice for selecting the data. As well, he has gone through the various number of data and algorithms, and he has suggested how to select the right algorithm for your applications. What is machine learning? He has defined very well. He has given the supervisor learning as well as unsupervised learning insight on it. The role of artificial intelligence and machine learning in modern mechanical system he has very well explained. Especially he has published tribological paper, more than 5 papers on AI and machine learning. Near about he has published 9 papers. He has published 25 papers, I think so, on Scopus, and 30 papers in conference. He has given all these kinds of many times of he has given this AIML for various audience. He has given insights on tribology. What exactly tribology is, how you can use the machine learning for tribological problems, just like friction and wear, how you can identify. Then how we can deal the parameters like sliding speed, sliding distance, speed, load, and filler content. And you can collect the data and you can analyze properly by using this system. And in the future, what will be it's a trend you can predict by using AIML system. So I personally thank for Gadde sir for giving such a wonderful session to the all participants which are in this session. Thanks for Gadde sir.
It's my pleasure, sir. Thank you very much for the patience of all the participants for this late night session.
Okay, Ritapure sir.
Okay, sir. Okay. Thank you, sir. Thank you.
Thank you, sir. Can I leave, sir?
Yes, sir. Yes.
Okay, thank you. Thanks a lot.